calculator. But what do you notice? It's a B. It is a B. It's opening up, right? It looks like this. Where is the vertex? Does that look similar to anything else we have done this chapter? Okay, so you get that in the calculator, but look at it. Do you see it in the equation? Doesn't that feel very similar to finding the vertex of a quadratic function? So maybe we can do that without graphing it next time. Which way does it open? The 3 is positive. It opens up. Sound familiar? Okay, then I asked you to graph this, just the absolute value of x by itself, just to compare the two. Is it wider or narrower in comparison? It's wider. So the 3 evidently makes it skinnier. It actually, the vertical stretch, those of you who had pre-AP algebra 2 will get there later this year, but it stretches it up, makes it look skinnier. So if there is a number in front like a 3, it makes it look skinnier. Really quick, just for fun, go type in a half times the absolute value of x. See what that is. So 1/2 absolute value of x. It makes it wider. So multiplying by a fraction or a number less than 1 makes it wider. Multiplying by a whole number makes it skinnier. So those are some things we're going to be looking at today. Today we're going to look at absolute value functions in standard form. I am not going to pick my calculator up this time, and I'm going to graph these equations. What is the vertex? And I'll give, hold on, I'll give you a second to write these. You got first one down. Go on with me. And then see if you can answer a vertex, which way it opens, and if it's wider or narrower than a normal absolute value graph. The absolute value of x. So what is the vertex? -1, 3. Any questions about that? Yeah. So remember from quadratics, they changed the sign of that, but leave that alone. From vertex form of a quadratic. So the vertex form of an absolute value is the same. And I can write that down. A times absolute value of x. It's always going to be the opposite. Opposite of the x, same on the y. Just like parabolas. So the absolute value, I just did that one today.
So if there's the bars, you would just change the sign in the middle. You wouldn't make like the negative or positive.
Right. For graphing purposes, it just turns out that the vertex is at HK. Just like a parabola. But we aren't actually plugging anything in to make it positive. We're just looking at the graph and we just notice that the vertex ends up in the same place as it did with parabolas. Which way does it open? Why? Because the 2 is negative. The A is negative, we're going to open down. If the A is positive, we're going to open up. If we're multiplying by a whole number like 2, a number bigger than 1, it's going to be narrower than the original. If we're multiplying it by a number like a half or a fourth, then it will get wider. So that kind of works a little. Numbers bigger than 1 are going to make it narrow. Numbers smaller than 1 are going to make it wide. The negative doesn't matter, it's absolute value piece. Because the negative actually causes you to flip it down, not the width. Does that make sense? So the negative tells you the up or down, the wide or narrow is just the number. I'm going to graph this without a calculator. I'm going to show you how to do that on a absolute value function. Now you can figure, don't get me wrong, just because I'm doing it without a calculator doesn't mean you have to. I'm going to plot the first x, -1, 3. The 2 acts like a slope, right? Kind of on an absolute value, because if you didn't have the absolute value bars here, you got the line. So the 2 acts similar to what a slope would do. So from this center point, I'm going to go down to right 1 and down to left 1. Now, why did I not go up at all? Because it's opening down, right? It's an absolute value graph opening down. Again, you do not have to do this completely without a calculator, but now you know that you can, and that's how you do it. Any questions about that one? Try the next one. While you're working this, I have your mastery exam for this quarter printed. I'm going to try to squeeze that in before Thanksgiving break. Do the first try next week, and then put the deadline on Monday before Thanksgiving break. Do y'all like that idea? Get that grade in, the 50 out of 50 in before Thanksgiving. If you have a big major problem with it, because it will be probably a day less than the 2 weeks I normally do, let me know if you do end up with a problem with that. The only people I would expect would be play people. If something comes up and you can't make it happen, just...
Teachers and students, please excuse the interruption. The ROTCs and the chamber choir are reporting to class at this time.
Our last day is Tuesday, right?
Yes, on Thanksgiving. Yes, but I'm going to make the due date Monday because my son's daycare closes at 3:30 on Tuesday. So I will have to leave. So Tuesday, y'all couldn't stay after school anyway.
So like their Thanksgiving break too.
Yeah. So they're not open on Wednesday, Thursday, or Friday. And then they're closing early on Tuesday.
What if you're not a teacher and you're not out?
Yeah. Good luck. Sometimes it's different, but some daycares are a little more flexible. Ones that have a lot of hospital employees, they never close.
What?
Kavanaugh Children's Center. It's like, Kavanaugh, all that church, South Fork.
Like Kavanaugh pizza?
We used to live in Fort Smith, and my cousin had a really interesting daycare, and he was doing really good at it, so I was She likes it. So we were like, well, my husband goes to work at daycare, so he drives, so he takes it. Yeah, we decided people suggested well we just leave it alone. Makes for a little bit longer drive, but okay, vertex is at 3, 4. Open. And wider or narrower?
Why?
circle.
Sure. As if there was a 1 there. So we're like multiplying it by 1, so it doesn't, it doesn't change. And let's look at how that would look. At vertex 34, I'm opening up. It would be like going up 1 over 1, right? Doesn't the normal absolute value go up 1 over 1? So it's not wider than a normal absolute value, it's not narrower than a normal absolute value, it's actually a normal absolute value as far as that goes. So I would probably accept a lot of answers on that, but it's neither wider or narrow. Any questions about that one? And that's going to be the same with this one, right? It's a negative, but it's still a 1, so neither on that as well. What is the vertex on this one? 1, negative 3 is the vertex. We open down. 1, negative 3 right here. We're opening down with a slope of 1, right? So down 1 over 1, down 1 over 1. How many of you find these even easier to graph than quadratics? Because you don't, the shape is easier to get because it's just 2 lines. So you just have to do a quadratic. Okay, writing the equation of an absolute value. This will feel very similar to writing the equation of a quadratic. And there's no square on these, right? It's absolute value instead of a square. What's the first thing we're going to pick out? The vertex. And what is the vertex? Negative 1, 3. So how does that translate to the equation? X plus 1 plus 3. Very good. Does everyone see how we got that? Just like with quadratics, what is the difficult thing to find? The slope. Now, I'm going to do this just like I did with quadratics, but could you just find the slope? So I'll show you both options. I'm going to go ahead and do this as if I know nothing. Plug in 3, 0 for x and y. Okay, we've done that on quadratics. So I'm going to put 3 for x, 0 in for y. 3 plus 1 is 4. And what is the absolute value of 4? 4. Subtract the 3 over. So A is negative 3. So my equation, the answer, is negative 3 fourths absolute value of x plus 1 plus. Very similar process to finding the equation of a parabola. You can see why, because it probably felt like it was weird that I put piecewise functions and absolute value functions in the quadratic chapter. You can kind of see why I did that now, because it flows well, makes sense. We can use our knowledge from quadratics to help us with absolute values. Now if I go, wait just a second.
Do we have any more quadratic ones?
I mean, you'll have a text over it, so you'll have a review with it. So yes.
It speaks to all inventions types because why would you make, like, with the bars, why isn't this kidding?
Well, you'll add first, like just like, they act like parentheses, so you'll do the 3 plus 1 first, and then you do the absolute value of 3 plus 1, which is, so 3 plus 1 is 4, and absolute value of 4 is 4. So that bars don't mean subtract. That makes sense? So you add first, and then absolute value. And the absolute value just, if it had been negative 4, it would become positive 4. But other than that, that's all the absolute values do.
So you don't change it if it's positive. Okay.
Nope. Okay, let's go look. I want to show you a little shortcut. Of course, this always use that on absolute values, which is nice. Any questions about that?
Why was it set 3 plus 1?
This, you do this first. Please excuse my parents, Sally. You multiply, well, this is multiplied by A, so these are not like this is 4A plus 3. And you can't add 4A plus 3. Okay, let's do more of those. We'll do one more of these because I feel like, did y'all understand the last one pretty well? One more. Okay, and let's pick number 7 because number 8 is too easy. Why is number 8 too easy? Slope is 1, isn't it? Up 1 over 1 or up 2 over 2. So you would not, the A would just be 1. So we'll do 1. What is the vertex? 3, 0. So what is my equation from the start? X minus 3 plus 0. And you don't have to write the plus 0 if you don't want to, since it's just plus 0. Okay, 2 ways to find A. The easiest way is to just find the slope, right? From this point, I go down 1, 2, 3. Rise is 3, run is 2. So it's 3 over 2. Positive or negative, and why? Why is it negative? Because we're opening down. Okay, any questions about that? Don't want to see me do the A the other way also. I said we'll skip A, but we'll just go ahead and do A. We'll do A. Or not find A the whole way. What's the slope? 1, right? 1 up 2 over 2. So 2 divided by 2 is 1. We're opening up, so that 1 is positive or negative? Positive. What's my vertex? 1, negative 2. So x minus 1 plus, oh, not plus, minus. Okay, any questions about that? The last thing we have for today is solving absolute value equations. This is a little tougher than the last 2 slides. Maybe. Does anyone remember solving absolute value equations before? Before I actually solve a complicated one, I want to solve a really easy one. Absolute value of x equals 3. And I want to ask you, based on what you know about absolute value bars, what do they do? What do the absolute value bars do? Make it positive. So what could I plug in for x and get 3? 3 or negative 3. So does everyone agree that the answer to this equation is 3 and negative 3? So that's what we're going to have to keep in mind. That what goes inside the absolute value bar could be positive or it could be negative. So in the first equation, would you all agree that 2x minus 4 equaling 8 would make that a true equation? But also, 2x minus 4 equaling negative 8 would make that a true equation. Because if the inside of that absolute value bar was 8, you would have a true equation. If the inside of the absolute value bar was negative 8, you would have a true equation. So here's how you set up every absolute value equation. You set up 2 equations. Set up equal to 8, set up equal to negative 8. That's how you set up every absolute value equation. Are those pretty easy equations to solve by themselves without the absolute value? What do we do? Add 4. Divide by 2. So I get x equals 6 on the top one. Same steps on the bottom, just with a different number on the right. equation is -2 and 6. How can you know if you did a good job? Plug it in, and let's do that real quick. What's -2 times 2? -4. What's -4 minus 4? And what's the absolute value of -8? Good job, we did good. So plug in 6. 6 times 2 is 12 minus 4 is absolute value of 8 is ding ding ding, we did a good job. Always check your answers on absolute value functions. And I'll show you why in a second. Sometimes we can make some silly mistakes with absolute values. Now let's look at the next one. I'm going to set this up with 2 equations. What are the 2 equations I'm going to set up? And does everyone see how to set up an absolute value equation? Equal to a positive and equal to a negative. How do I solve that? Take a 0 on side factor, right? This is a quadratic equation. I can know with this, right? So subtract 6. In the second one, we will actually add the 6 over. Do 0 on one side, and hopefully they factor. What are the factors of 6 to subtract to give you 5? 1 and -6. Good. So x is -1 and 6. Okay, on the right.
Oh, you said.
You sure? Yeah, factor it. So anytime you have a quadratic, try to factor. If that doesn't work, then you have to go to quadratic formula. We hope it works. We don't refactor. Sure. Which part do you want me to explain? The factoring? Yes. So we want these 2 numbers to multiply to give us 6, and then add to give us -5, or -6, +1, and give us 2 and 3, x minus 2, x minus 3. For this one. And so 2, 3. Check them. Make sure we didn't make a mistake. Make sure those answers are good. Because we're adding to get -5. We're adding to get -5 still, but this time they have to multiply together to get negative, and it had to be opposite signs. Okay, -1 squared is 1. -1 times -5 is 5. 5 plus 1 is 6. Did the first one work? Yes. 6 squared is 36. 5 times 6 is 30. 36 minus 30 is 6. Does that one work? 2 squared is 4. 4 minus 10 is -6. Absolute value of -6 is 3 squared is 9. 9 minus 15 is -6. Absolute value of -6 is? They all work, right? So check them. I'm doing it in my head. You do not have to do that. Type that in the calculator real quick. Yes.
-1.
Put the -1 in parentheses. -1. Well, you can replace it, particularly on the square. Because what it's doing, it's squaring -1 and getting -1, which we know is not good.
On the first one, why is that one negative?
Do you know why this is positive?
Oh,
Good. X minus 7 and absolute value x squared minus 7. Okay. This one, the biggest thing on this one, and why I wanted to show you this one, is you don't have to do parentheses on this problem. I'm going to set up, like always, two equations. I'm going to set up x minus 7 equals x squared minus 7x. That's the first equation I'll set up. The second equation I'll set up, I have to make the right side negative, correct? So I get x minus 7 equals negative x squared minus 7x. If you don't put these parentheses, you will mess the problem up because the whole side has to be negative. Or you can distribute the negative from the get-go, but these are well, you always do 1 equals a positive and 1 equals a negative. So it's the negative. Yeah, it's the other equation. So on this one, big thing to be careful about is if there's two pieces on the other side, make sure you put the negative with both of them. How do I solve it if it has an x squared in it? Maybe get 0 on one side, factor. Unless it's just a perfect one that's square roots. Other than that, we want to get a 0 on one side and try to factor. So, the one on the left, if I were you, I would move everything to the right. Why would I do that? We like x squared to be positive, don't we, when we're factoring? We've never dealt with an x squared being negative. So, I'm going to subtract x. So, I get negative 7 equals x squared minus 8x. And I'm going to add the 7 over. Factors of 7 that add to give me 8. Negative 1 and negative 7. Very good. Second equation. So I'm getting faster when I'm showing one of these in class. Jacob, you wait. Jacob. I'm getting a little faster when I'm going through these factoring problems. If you still need help with factoring, please come see me. That will hurt you all year long if you can't factor. Right? Have y'all noticed that? There's a reason I put that on that first mastery quiz, because if you've got to know how to factor, almost every chapter in college algebra you have to know how to factor. So come see me. This one I'm going to do everything to the right or to the left. Why would I do that? Because I don't want the x squared to be negative. I'm not good at factoring if the x squared is negative. If you're using quadratic formula, it wouldn't matter. But those are not like terms. I just get x squared plus x minus 7 equals 7x. Subtract the 7x over. X squared minus 6x minus 7 equals 0. One and 7 subtract to give me 6. Negative 7, positive 1. So I got 7 twice. That's okay. Again, go check them. Okay. 1 minus 7, what is 1 minus 7? Negative 6. Absolute value is that good so far? Okay. 1 squared is 1. Minus 7, what do I get over here? Negative 6. Does this become positive? So it's positive 6 equal to negative 6. You see why we have to check them? Remember me telling you we're going to have to check them? I'll show you an example in a minute. So this is 1. We did everything right, didn't we? But that's not right. So we've got to go down and say, okay, we did everything right, but the 1 doesn't work. So we're going to cancel it out. It didn't work. So you have to check on absolute value equations. It's not an optional thing. On some things it's optional. Quadratics, we're just checking to make sure it works, make sure we didn't mess up. This time we're checking to make sure the equation didn't mess up. Plug in 7. 7 minus 7 is 49 minus 49 is, that one's good. And then what was the other 8. The absolute value makes positive 8. Negative 1 squared is 1. Negative 1 times negative 7 is positive 7. 1 plus 7 is 8. So that one works. Everything works except the positive 1. So my answers are 7, negative 1. And it's 7 again. If you write it twice, that's fine. 7 and negative 1 are the only two answers. The 1 didn't work. So be careful about that. Your homework is a worksheet. The first 6 problems are matching. I just wanted you to know so you just get confused. Those are just matching problems. Write the letter beside the number. Let me know if any of you don't yet.